Ladies and gentlemen, welcome to this core CeSAM special lecture on confronting uncertainty given by Professor Lars Peter Hansen. My name is Leonardo Iania and I am the director of the Center of Study of Asset Management, the CeSAM, and I'm also an associate fellow at the Center of Operational Research and Econometrics, the CORE. I'm really honored to welcome you today to this lecture, which is a key event for both the CORE and the CeSAM. For the CeSAM, the visit of Professor Hansen starts an exceptional year where we will have the visit of many other distinguished scholars, such as John Campbell, John Cochrane, Frank Diebold, and Eric Geisels. For the CORE, this talk is part of the 50th anniversary celebrations, which entails events spanning over the entire year. The common denominator of these celebrations is the motto, bridging gaps. Gaps between generations, gaps between scientific disciplines, gaps between the past 50 years of CORE and the next one. The lecture of Professor Hansen is the first event in the field of econometrics in the context of this celebration. We could not have hoped for a better start. To describe the field where Lars works, I use his own words. I work on the boundary between economics and statistics in this field called econometrics. The work of Professor Hansen has bridged gaps between the fields of statistics, economics, and finance. He has shown us the way to test economic models with the minimal effort, if I can say. To give you an idea of who Professor Hansen is, I use the quote of one of the greatest economists of our time, John Campbell. Begin quote, "I have never forgotten the first conversation I had with him about financial econometrics, in which I sensed his penetrating insight that would require effort to fully understand, but without amply reward for the undertaking." End quote. If you work in the field of economics, finance, or econometrics, you probably have estimated the parameter of your models by using the generalized method of moments. If you do not work in those fields, you probably know Lars because he has won the Nobel Prize for Economics in 2013. If you were to dig a little bit on the internet, you will discover that he closely works with other Nobel laureates like Professor Sargent. You will also discover that he is the David Rockefeller Distinguished Service Professor at the University of Chicago. And you will discover that he is also the head of the Baker-Friedman Institute. You will discover also that he has won many other prizes, which I'm not going to list here. But if you were to talk to him, you will find in front of you an extremely simple, generous, and kind person. His kindness can be compared only to his brightness and his deep knowledge. If you talk to him about economics or finance, you will have the impression of having in front of you a living and forward-looking encyclopedia. As John Cochrane says, Lars writes for the ages, and it often takes 10 years or more for the rest of us to understand what he has done and how important it is. It is therefore a very honor for us, Professor Hansen, to attend your lecture, Lars, because we are sure that the work that you are currently doing will shape our future research and understanding of the interaction between economics and finance. In his novel, The Importance of Being Earnest, Oscar Wilde says, "Uncertainty is at the heart of romance. I think that in a few years, we will discover that uncertainty is at the heart of the relationship between economics and finance. Before leaving the floor to Professor Hansen, I would like to thank a special person that is here today. Is the founder of CORE, Professor Jacques Drèze, who founded the CORE 50 years ago. So Lars, you have the floor.
Thank you. I'm certainly honored to visit UCL today, and it's my privilege to participate in the 50-year celebration of CORE, and to have the opportunity to share some ideas with you. So I'm going to talk about topics that certainly are important to me, and namely the impact of uncertainty on economic analysis. As Leonardo mentioned, my research has been aided by prior work in mathematics, statistics, and finance, along with economics. I find that building bridges between fields fosters intellectual advances. While uncertainty is pervasive in our lives, in many discussions of economic analysis and policy, it takes a back seat. I'll discuss ways and reasons that we should instead push uncertainty to the forefront of our thinking. As an economist, like other economists, I build mathematical models. Why do we do this? Well, for a couple of reasons. One is we want to represent clearly our understanding of the economy, but also to predict what happens when the economic environment is altered, such as changes in government policies, tax policies, exchange rate policies, monetary policies, and the like. I wish I could tell you, predict today what would happen to the U.S. If Donald Trump became our next president, but I'm not going to embark on that one. Yes, I'm still trying to assign probabilities to that event. The models that fascinate me are ones that are ambitious enough to confront macroeconomic questions and rich enough to feature a role for financial markets. Uncertainty is central to the models and how they're used. Capturing this uncertainty in a formal way is essential to the endeavor. The models are dynamic. They capture the evolution over time of economic variables that are stochastic. We introduce random impulses or shocks that are transmitted through the economy. This randomness, however, is only one aspect of uncertainty. Models we use, like in other disciplines, are not exact replications of reality. They are simplifications, and hence not perfect. Rather than dismiss imperfect models, I prefer to use them in sensible ways. The nature of these imperfections contributes to uncertainty when broadly conceived. The models that I work with incorporate reluctance to go forward with some new ventures in very uncertain times. Moreover, they provide a more feasible and sober framework for assessing economic policies. So what I hope coming out of this talk, I'll leave you with a little bit of a different perspective on the importance of uncertainty and certainly in economic analysis. So I'm going to get started with, I'm going to start with this painting of Pascal. If we think about probability theory and its origins, it really began as a study of the games of chance. We start using probabilities to capture what happens when we roll dice, when we flip coins, and more complicated versions of these. These are situations in which we don't know outcomes, but we know probabilities. Okay? And this is kind of at the origin of the whole probability theory. If we go to how probability meets social science, so here I've spliced together a couple interesting depictions here. Really, the first person who really thought about using probability to confront social scientific data was Jacob Bernoulli. And as many of you know, Jacob Bernoulli would, among other things, produce the so-called law of large numbers, how unknown probabilities get revealed through repeated evidence. We have repeated coin flips, we learn more and more about probabilities. So this takes us from a situation where we know probabilities, not outcome, to a situation where we don't know probabilities and have to use evidence in order to proceed. So Jacob Bernoulli kind of sets the stage for lots of the discipline of statistics and many aspects of the discipline of econometrics. Now, how about on the right-hand side? The right-hand side is a painting by Pizarro. It's a painting of a marketplace. The reasons I've spliced these two things together here is the following. As economists, we also have to model people in marketplaces. When people come to a market, they don't know the price is gonna, they don't know what price is gonna be, other goods will, what prices will, other goods will command. They don't know how much demand there's gonna be for their goods. They have to make some guesses, but they indeed face uncertainty. So not only is there an uncertainty of the type that Jacob Bernoulli thought about, this outside perspective, looking at data, trying to figure out probabilities, there's people inside our model, and they also have to be doing stuff like this. And there's interesting questions about how we put all this together. So this leads me to thinking to the following distinction that I find useful. There's uncertainty in economic analysis is outside the model uncertainty. That's more like the kind of Jacob Bernoulli type uncertainty. Given some dynamic economic model, researchers, econometricians and the like, they have to estimate unknown parameters and they assess model implications. And so a lot of the field of econometrics is kind of about this and how to, and subtleties and complications in this type of enterprise. However, we have to apply these tools to a model, and now suppose we go look inside a model. So the model itself is a dynamic model, and the researchers have to depict economic actors, consumers, enterprises, firms, even policymakers as they cope with uncertainty. Then the challenge is to deduce the consequences for market outcomes and resource allocations. So there's two different perspectives. So there's the outside the model perspective and the inside the model perspective that are important to economists. And and kind of going back and forth I find to be tremendously valuable. So let me try to draw just some various challenges then just to illustrate things. So if we might confront an urn with a known fraction of yellow balls and red balls. We might draw randomly out of that urn. That's a situation where we know probabilities, but we don't know outcomes. Games of chance. We may not know the number of red balls or yellow balls. So this is the case of Jacob Bernoulli looking at social scientific data and trying to figure out probabilities. Now, in time series, we can make it one step more complicated. We can imagine there's different urns at every different time period. Maybe there's some similarity across the urns, but maybe the numbers of yellow balls and red balls changes over time. And so now we're trying to chase something of a moving target. And so, in many respects, I think this is a real challenge facing lots of aspects of economic analyses. So for me, I like to think about there being multiple components to this uncertainty. The first comes under the heading of risk. And the tools of economic analysis are very rich in terms of how we capture risk. And risk is about what probabilities a model assigns to events in the future. The events in the future are uncertain. The model tells us what probabilities to assign. So the treatment of economics of uncertainty is largely within the setting of risk. The probabilities are kind of given, and then we figure out what are smart decisions to make in the presence of those probabilities. There's model ambiguity. We have multiple models on the table, and we don't know which is the correct one. So here's where statistics starts coming into play. We might have multiple models. We could take a so-called Bayesian perspective, assign probabilities across those models. We could use data to try to figure things out. There's issues about how we assign those probabilities across models, given that it's based on so-called prior information, and there may be uncertainty in terms of how we specify that prior information. There were some very great probabilists and statisticians, DeFinetti and Savage. In fact, Savage did his important work at the University of Chicago, I'm proud to say. But they kind of developed this very rich theory of so-called subjective probabilities. It helps with this issue of model ambiguity, how much confidence. So we kind of think introspectively to help us formulate, to fill out probabilities, like probabilities across models, not based fully on evidence. But even DeFinetti and Savage were quick to concede that the assignment of these subjective probabilities could often only be done in very imprecise ways, and that's quite a challenging task, and one may well want to be doing sensitivity analyses in conjunction to the assignment of prior probabilities. So even the most richest axiomatic formulations here, the people who developed those axiomatic formulations had some skepticism about their full usage. Finally, let me get into model misspecification. The models we use, they're wrong. They're simplifications. We know they're simplifications. They're not even meant to capture everything. They deliberately leave things out. So how do we use a model that we acknowledge is not perfect, and how do we so-called confront misspecification? In many respects, this is the hardest of the three components of uncertainty to address, but perhaps also the most important. It's the one in which it's not easy to give lectures about it in econometric classes about how to proceed with this, but I think it's tremendously important considerations and fundamental to to how we think about uncertainty. So here's a painting. It's a painting by Latour. This painting has a bit of a story to it that is a slight embarrassment to my co-author, to Tom Sargent and me. This painting shows up on a book cover that we have. And the painting shows up on the book cover without the person all the way on the right. It's a painting from the Louvre, and our publisher made us do this. That's my apology for this. So my colleague, who's an expert in the history of statistics at Chicago, Stephen Stigler, notes that this painting picks out the fact that we truncated he writes an essay on the current perspective on robustness in statistics, pulls out our book cover, notice that we truncate the person on the right-hand side, and suggest by so doing we kind of undermine an important meaning of the whole painting. I contacted Steve, who's a friend of mine, to say, this wasn't the most friendly treatment of our work, and he assured me that all publicity is good publicity, and that he helped our book sales, and he was looking forward to compensation for his advertisement. But anyway, in many respects, Stephen Stigler was correct in his analysis of this, that our book does not do justice to the Latour painting. So let me just talk through this painting, why it's even up here to begin with. This painting, not surprisingly, is called The Cheat. There's another version of it in a museum in Texas. Some people even speculate that one of the two versions itself is fraudulent, but that's not. But so it's this person on the right-hand side thinking that he's playing a game of cards, just like a standard, maybe a game of chance, and maybe standard rules of probability might apply to help him figure out how to perform and participate in this game. Then you look more closely, you see the dealer with somewhat shifty eyes. You look at the person pouring the wine potentially in on this, and then the person with hiding cards behind his back. So the question is, so I'm using this picture somewhat metaphorically to think about, well, we could use our models very naively as if they give us all the correct probabilities, or and then we might run the risk of being potentially duped by these card players. Maybe the real world comes back and bites us in the sense that, well, you've left off some important components of this model, and if you use it naively, it's going to turn out to be costly. So instead, I would imagine that we should try to keep our eyes a little bit open to how our models might be wrong, and to try to guard against activity like this. So let me now turn to some interesting issues. So here's I've just graphed some plots of real GDP in both the U.S. and in the Euro area. And so what happens is kind of where this fact, the so-called financial crisis hits, and there's a drop in real GDP. in both the U.S. and certainly in the Euro area as well. That the U.S. And there's becomes issues about, well, if we have this drop, how quickly are we going to recover? This has been a so-called stunningly sluggish recovery, and the question is there some permanence to this drop, or are we eventually going to kind of revert back to some rough trend line or the like? And this is the evidence which we're confronted with. And this has led lots of people to speculate about the so-called secular stagnation. There's been debates by Bernanke and Summers about whether we're in a situation of permanent stagnation, or is this something at the end of the day we're just going to eventually come out fully. There's kind of long-term discussions as well. There's this is based in part on interesting research by Joel Molkier and by his colleague Robert Gordon. Robert Gordon's recently written a very kind of comprehensive book about the rise and fall of growth in the United States over very long time periods. And there's debates. Is the great successes of what Gordon refers to as between the 1870s and 1970 centuries unique, and we've kind of reached the limits of these, and going forward, we should not really expect the same type of engines of growth to be proceeding. Or Joel Molkier, who's much more optimistic, perhaps mentioning that perhaps the technological innovation itself creates questions and problems that will need to be fixed through further technological progress. There's a question mark here for a reason. That is, the truth is we can have people state opinions with great confidence, but in truth, we're not really sure. There's lots of uncertainty about growth, both over the next few decades and even over longer time periods. And how do we? And what are the consequences of that uncertainty which we face? We're not even sure kind of what the right way, what the right perspectives or even the details of how to model growth going forward. Is secular stagnation or something of great permanence, or is it something which we will? There's going to be simple means to get out of going forward. Now, there's kind of related evidence that come from so-called financial market data, and if you kind of read some of the private sector discussions of so-called financial markets, even looking over very short-term investments, there's this so-called risk-on and risk-off language people use. I would prefer. I don't like to think about this as pure risk in the sense we talked about earlier. And this has just some metaphor, some way to say that investors' so-called appetite for risk rise and fall over time. And really, what does that mean? Their appetite for risk rises and falls over time. I mean, there's academic research that is capturing a related phenomenon, maybe essentially the same empirical phenomenon. So-called, there's time-varying expected returns that are observed, characterized. Financial econometricians spend lots of efforts devoting, trying to characterize these. And basically, the measured risk-return trade-offs from financial markets fluctuate over time. There's evidence that so-called risk prices are bigger in magnitude sometimes than others, and the sometimes tend to be times of connected to bad times from the perspective of the macroeconomy. The question is, what explains these movements, and how do we build models that can really capture these type of phenomenon? And really, is a pure risk story the right way to go? There has been literature in economics which has pursued this other risk approach. Investors inside our models have all the probabilities figured out, and then we put inside the model so-called stochastic volatility, processes that move things around kind of exogenously without really having good stories for what precisely these processes are. They're kind of necessary to account for data under the kind of the risk rational expectations approach to model building. There's also some approaches to thinking more long term. What happens to what's the evidence about the so-called prices of exposures to long-term uncertainty, which are certainly very much relevant to the so-called secular stagnation discussion. There's asset pricing evidence that suggests that risk adjustments are prominent, that long-term risk adjustments are prominent in asset pricing. Looking at comparisons between what goes off, between term structures of interest rates and what goes on in equity pricing and the like. And an example of this type of research is kind of Alvarez and Yearman, but there's others as well. Now, there's been interesting research that's been builds off of insights of Charlie Koopmans. Charlie Koopmans was working, decades ago about how to think about very interesting and more general ways to represent preferences of people, of consumers and investors and the like. And this work was kind of developed more fully by Krebs and Porteous, and in order to come up with a concern for the intertemporal composition of risk and how to get preferences that make that intertemporal composition really matter. They're after drawing distinctions between the following. Imagine you've got a situation in which you, this is a purely hypothetical. Suppose what you do is you flip a coin every period from now into the future. If the coin comes up heads, you get high consumption. If it comes up tails, you get low consumption. Compare that to an experiment where you flip once, and if it comes up heads, you get high consumption in all periods, and tails, you get low consumption in all periods. So in one set of circumstances, you're flipping every period. Yet the other set of circumstances, you're just flipping once. Standard models of risk aversion that we teach in most of our classes make investors indifferent between those two types of gambles. And many people, I guess, which might be sympathetic to the notion that if you do the kind of flipping every period, there might be a preference for that type of outcome. And so that's a situation where the intertemporal composition of risk matters, and so people have been working on preference specifications that capture this. These are important in asset pricing by Epstein and Zinn and others, and connected to growth rate uncertainty by Bonds on Your Own. Now, the stories, those are all risk stories, and I find it convenient to reinterpret these type of, using investor concerns about model misspecification. If we're going to assign probabilities to long-term uncertainty, it's a challenge. I think it's a challenge to do it with kind of full credibility. And so it's an alternative way to interpret some of this evidence having to do with, well, investors themselves are not fully confident in the models they use. And that's some ideas I pursued with my colleague, Tom Sargent. Now what I'm going to show you is kind of a way to represent uncertainty prices over long horizons using a counterpart to what people in mathematical finance call risk-neutral probabilities. So the field of mathematical finance is about how to go through and take some primitive financial market data and do things like assign option prices and the like. And it uses a so-called risk-neutral probability measure. It changes the probability measure in a way that absorbs all the risk adjustments and then does the calculations with this alternative probability measure. Well, there's a different such adjustment for every different investment horizon, and then as you go to over the long term, there's kind of a limiting counterpart to that. And that's a way to express kind of long-term risk adjustments, or more generally long-term uncertainty adjustments. And so I just give you kind of using one of these structural models of the type I've just described, just illustrate the type of outcomes that come out of this. Imagine we've got an overall macroeconomy that's characterized by some type of growth rate. There's a macro growth rate that behaves like some stochastic process, and there's so-called stochastic volatility in the macroeconomy. And suppose that the growth rate process is kind of normalized to have mean zero, then we might have a probability distribution over the values of that process given by the different where the different kind of level sets of the density are given by the different lines in that blue figure. And the denseness just means that you're picking out the points at which the density is getting higher and higher. Then the way these kind of long-term adjustments for uncertainty work is they can be captured in a shifting probabilities perspective. If you make the probabilities absorb all this adjustments for long-term uncertainty, you then change that blue figure to this red figure. And in this red figure, you can see what's happened. Well, there's the curve's been shifted down to a more conservative posture. It's gone from zero the zero kind of centering point on this vertical axis to something lower, and it's also shifted to the right to kind of more volatility. So the way these risk adjustment shows up here is it has you use a different probability that in some sense is more pessimistic or more cautious, and it's captured by the right figure here. This is all calculations, these are all long-term calculations, and they require kind of a structural model in order to produce them. So part of pushing uncertainty to the forefront of economic analysis, there's different ways we can imagine doing this. First, we could increase exposures to uncertainty. So we can just say, well, maybe in the past we haven't measured exactly the right amount of uncertainty. So when people start talking about so-called tail probabilities, or maybe the distributions we're using don't have enough action, off into some tails, and every now and then we observe really bad outcomes. That's an example of increasing the exposure to uncertainty. We can also work on enhancing decision-maker concerns about uncertainty. So drawing this distinction between those two coin flip experiments I gave you, it would be an example of changing decision-makers' concerns about that uncertainty. The intertemporal composition of risk might indeed matter in important ways. Finally, then economists, macroeconomists, and people in finance have been imposing frictions in financial markets motivated by the recent financial crisis. Unfortunately, in order to make those stories work, we also kind of have to invent shocks to those frictions. So macroeconomists recently have been incredibly creative or something about inventing shocks. Macro models these days, I guess, would have somewhere between 10 to 15 shocks with various different labels. I could not even reproduce all the labels, but there's a non-trivial question about what these shocks really are, and can we probe much more deeply for a more fundamental understanding. And so it's my view that the interplay between these three things is really is potentially very important. And looking for more endogenous sources for these variations and fluctuations rather than imposing it on the outside by just inventing new shocks. So when constructing these dynamic models, the question, I find it valuable to imagine, as I said, we have to depict our economic actors as they cope with uncertainty. And because people make investment decisions, and where investment should be thought in very broad terms. It's just not financial investments. It's investments in how much education and what type of education you want to get is in part linked to your guesses of market opportunities, which will be available to you after the education, or what type of job opportunities will be available to you, or career opportunities will be available to you going forward. So when I think about investment, I really want to take the broadest notion of this, and lots of it, so it kind of is pervasive in economic activity. And then we want to deduce these market responses, the consequences for resource allocation. So by broadening the notion of uncertainty, going beyond these risk models to incorporate, concerns about ambiguity, how do we weight alternative models, how do we treat models that aren't really fully correctly specified, I view as an opportunity to build in more richness into our analyses. So we can imagine models in which investors, broadly conceived, struggle with how to perceive the future in a meaningful way. Secular stagnation, does it exist, does it not exist? They might approach this struggle with the differing degrees of confidence in their beliefs. Some may have full confidence in their models, others may take a more cautious perspective to those models. Then, to get dynamics, interesting sources of fluctuations, the impact of that struggle itself can vary over time as new evidence or perspectives emerge. The outcome of trying to put all these together then gives you new sources of fluctuations in uncertainty of prices that emerge in financial markets. So it allows you to confront these time-varying risk premium, allows you to confront this risk on and risk off. But moreover, concerns about long-term uncertainty can be shown to even influence short-term pricing. So concerns about where the economy is headed in the long term can even affect the short-term risk-return trade-offs in say financial investments, and so this kind of long-term, short-term connections get forged as well. So not only do we get new sources of variation, we also get interesting links that go on between the two. But here's an example of the type of uncertainty time series, which this is a case in which we're looking at this. I begin with a model. It's a very simplified model in which the so-called the so-called risk prices would be constant over time. And then I ask, what happens when we introduce into that these kind of investor struggles? The investors don't take the models so literally. They introduce potential misspecification. Now, how do you introduce this potential misspecification? Well, for us, we're a model builder, so we have to do this in some type of formal way. And the formal way says we have to throw a lot of different possible probabilities onto the table. And so we have formal ways of doing that and in ways that are tractable. And then look at the utility consequences, or the consequences to the investors of these alternative probabilities. And then start thinking about shading decisions towards probabilities that have that are most consequential to the decision maker. Okay, and those are kind of all endogenous calculations. And so this is an outcome of a model that starts in which these uncertainty prices are constant and illustrates the type of fluctuations that can come just from the struggle, not from throwing in new shocks, but just changing how people respond to existing shocks. And so what I want to get you, this picture, this is a model that has two different types of shocks. It's got a kind of a level shock to the macroeconomy and a growth rate shock, and the blue line corresponds to the growth rate shock. But then what I want you to get out of here is that in kind of bad macroeconomic times, you see these prices getting bigger than in good ones. So it kind of shows up in the in the U.S., the so-called Volcker recession in the 80s. It's showing up in the financial crisis more recently as well. This is only fit to macroeconomic data. I'm not looking at financial market data and reading directly what the fluctuations are. I'm taking a purely macroeconomic calculation and saying, how can the macroeconomic uncertainty contribute to financial market volatility? And so this is like an illustration of what can happen there. The mechanism behind this is kind of investors shading their probabilities, thinking about, well, I've got this original model. This original model is an approximation. It's not literally true. I'm not going to take the probabilities coming out of that model as being literally the correct ones. I'm going to have to look at that probabilities in the statistical neighborhoods of that model and start looking at their consequences. And then we look at models that are, from a statistician's point of view, very close together. Something that would take a statistician very long and rich data sets to ever have any hopes of telling them apart, which often don't exist in practice. And then once you start guarding against this, then what happens is that you begin by this cone-shaped region, which are the quintiles off of the So this is a plot of how macroeconomic growth is evolving over different horizons. Under the original baseline model, the mean is just that black line. Right? And so it's kind of like a trend growth, but then the uncertainty gets magnified as you go further and further horizons. And so the original cone-shaped region, the more gray region, comes off the original model. The other one shows you what happens as you, with these kind of probabilistic forecasts, as you start shading things in a more conservative direction. As you start looking at your utility function, trying to figure out things which you are most concerned about, and that leads you to kind of twist this distribution in a more conservative direction. And so so instead of risk aversion, where this twisting is coming because of a concern about model misspecification. In model misspecification, that a statistician would consider to be small. So I find it very useful to ask, economists and financial people and people in finance often talk about behavioral anomalies and when does the unusual behavior take place. I find it very useful to connect those type of questions into when is the historical evidence strong and when is it weak. And if the historical evidence there is weak, then it opens the door to much more opportunities for behavioral biases than when the evidence kind of makes it easy to rule out those type of distortions. So anyway, this just illustrates the type of mechanisms which we've been looking at. So now let me turn to the policy questions, to some uncertainty in macroeconomic policy. So there's a quote from Hayek. So Hayek, as many of you know, got the Nobel Prize. He shared it with Myrdal, who was very, very different from Hayek, and it was no doubt an interesting pairing that took place. I have a little bit of sympathy with this, having been paired with Fama and Schiller in my own award, and that was a peculiar experience, but I'm sure with Hayek and Myrdal it was even more so. So Hayek gets the Nobel Prize in economic science, and he proceeds, whenever you get the Nobel Prize, you have to write, you're supposed to write some essay and trying to put your work in some type of perspective. So Hayek, when he writes this, his essay, really questions the extent to which economics is a science. So it's kind of a really intriguing essay in that regard. He's clearly struggling with the sense of which economics ought to be viewed as a science. He's more cautious on that front than I would be. But here's this quote here about policy that I think is really very, very relevant. Even if true scientists recognize the limits of studying human behavior, as long as the public has expectations, there will be people who pretend to believe that they can do more than what is really in their power. So I think there's kind of this bias in our discussion of economic policy, whereby people who give the advice think they have to project this public images of a kind of a pretense of knowledge. Acknowledging uncertainty in your answers is viewed as kind of as a sign of weakness and a way to undermine your ability to influence policy. And I view this as not a very comfortable situation. Now, indeed, economists who give policy advice understand there's lots of uncertainty in their answers, and even policymakers who take that advice, which probably realize this. But a lot of the public discourse puts all this stuff to the side. And I think to have really sensible discussions about economic policy, uncertainty should be at the forefront and not something that's just buried. So in terms of, so let me talk a little bit about monetary policy. I'm going to appeal to a little bit of history of thought as well as some recent discussions. So this is Milton Friedman, who was, when he talked about monetary policy, kind of would often refer to things like so-called long and variable lags, and use that jargon in order to convey a lack of full understanding of the monetary transmission mechanism to the macroeconomy, asserting that there's a lack of full understanding of that. And then he took that one step further to say, therefore, maybe we ought to be looking at, or arguing that we should be looking at more simplified monetary policy rules based on the fact that we really didn't have a full understanding of the transmission mechanisms. So here's this quote. This is Friedman quoting, Josh Billings, who was a kind of a humorist in the U.S. from the, I think, from the 1800s. As Ross Brilling wrote many years ago, the trouble with most folks isn't so much their ignorance as knowing so many things that ain't so. Pertinent to this remark is to economics in general, it's especially so in monetary economics. So it's that's kind of a statement about, or a concern about pretending to know too much. In the U.S., we've had undergo lots of discussions over the past year or so. Is the Fed going to hike, or is not the Fed going to hike? They finally recently hiked, and then the next meeting they decided not to, and then there's kind of there's still kind of seem to be waffling a little bit, going back and forth on this. And then you have to ask yourself, at what point in time would you be better off just announcing a much more clear path, and instead of adding this uncertainty into the underlying outcomes. And this is kind of what Ken Rogoff was trying to capture with this quote. It's wrong to vilify the Fed for hiking, and it's wrong to vilify it for not hiking. If it's such a close call, it probably doesn't matter so much. But at this critical point, it's fair to ask the Fed for a much clearer message what its strategy is and what this implies for the future. So this is again the statement that, maybe we're spending too much time on the wrong question about whether you should hike or not, and kind of going back and forth, and maybe we should instead figure out how to get clear messaging out there in order to reduce the amount of policy, uncertainty induced by policymakers. So this leads to the interesting question, which I think is not fully settled from an analytical perspective, but I think is tremendously important from the standpoint of policymaking. This goes back to Friedman's call for simple rules in situations where we don't understand things, and others as well. So let's take the problem of financial market oversight. After the financial crisis, I went to many different conferences in which people from various central banks would kind of get up and really make it clear this is a complicated problem, how to do financial market oversight. And it certainly is filled with lots of complexities. There's lots of, and then they would say, therefore, it's a complicated problem, so therefore it necessarily follows we need complicated solutions for it. And I think that is not so obvious, actually. Once we start acknowledging the limits to our understanding, the linkages between financial markets and the macroeconomy, it's perhaps no longer the case in which you necessarily want to, in the short run, address things with complex solutions. It may be that specific models we write down imply alternative complex solutions. So if I had complete confidence in some model with all of its complexities, that I could figure out the right course of action for that model. But once we start looking across models, and once we start looking and see how the policies might perform across these different possible models, it may well lead us to a situation in which we're doing more simple, transparent things. Robust policies are ones we want to perform well across models in which we have a hard time telling apart based on historical data and prior reasoning. And it may well be that simple, robust that's the simple versions of robust policies avoid adding uncertainty to the economic environment, and that as well, the simplicity as well can be contribute to the reduction of uncertainty. Part of complexity in policymaking is this issue of transparency. It makes it easier for policymakers to engage in discretion, which in very extreme times might be necessary, but perhaps not all the time. But it also makes it it also adds to the underlying uncertainty, but the more that you start filling with potentially complex rules. So I think there's lots of potentially interesting reasons for wanting to feature simplicity. Now, simplicity alone isn't a good answer. We can have simple bad things and simple good things. So I don't want to say so. You still have to look at what are good and bad policies. But it says, but there's a. I think in situations where your understanding is limited, that there's that simplicity is something that requires serious consideration. So let me now turn to, so I'm going through the hard problems of the day, financial market oversight. So since we just solved that, let's go to climate change, another easy problem to solve. But anyway, I think in a lot of the discourse among the scientific community on climate change, there's a little bit of a concern to acknowledging how much uncertainty there is in the models which we use to predict climate change. If you look at those models, they are really complex, but they're also not right. There's known defects in them. There's this statement by Peter Koonin, who's a former Undersecretary of Science in the U.S. that I found to be very, very valuable, or very, very useful statement of kind of productive ways to go forward. Any serious discussion of changing climate must begin by acknowledging not only the scientific certainties, but also the uncertainties, especially in projecting the future. Recognizing those limits rather than ignoring them will lead to more sober and ultimately more productive discussion of climate change and climate policies. I think there's somewhat of a fear that we have, that if we acknowledge uncertainty in our answers, then our answers will just be completely dismissed. And I think instead what we need to, a more fruitful thing to do is to acknowledge the uncertainties, but then figure out sensible things to do in the presence of those uncertainties. For instance, things like taxing carbon consumption and the like may well be a relatively simple and straightforward policy to implement, and it may well be a useful thing to do, even if we're not fully confident in understanding how carbon emissions will influence the climate going forward over the next several decades. So let me kind of summarize, and then in a few different ways. So what I've tried to feature in today's talk is two perspectives on uncertainty. There's this outside the model uncertainty and inside the model uncertainty. Outside is that of the usual statistician. The statistician's given a model or a family of models and is supposed to do stuff with them. As economists and other social scientists, we've got people inside our models. They also cope with uncertainty. So the question is, I find it valuable to think about the perspectives inside the model in similar terms as those outside the model. the first part of my professional career, I was an econometrician using so-called rational expectations models. And these rational expectations models, rational expectations has been a demonstrably successful construct within economic dynamics, and it's indeed been a very powerful one. But it involves the simplification that people inside our models have figured out all the probabilities. They themselves know the models and figure stuff out, and it's just us econometricians or statisticians outside the model that might have to engage in struggles. And I can believe that some private sector people might be smarter than econometricians in some respects, but the question is how. I would like to think that gap isn't so huge, that perhaps some of the same struggles that the statisticians are facing are also relevant inside social systems. And so I think it's interesting to try to take these perspectives of uncertainty and put them all the way inside our models. I find it valuable to enrich our models of uncertainty because it changes how we measure exposure to uncertainty. It changes how we measure the prices and consequences of that uncertainty. It also, I believe, changes how we should approach economic policy. So in closing, I'm going to appeal to two different authorities. One is Confucius. Real knowledge is to know the extent of one's ignorance. The other is Mark Twain. Education is a path from cocky ignorance to miserable uncertainty. Hopefully the message you're taking out of here is that uncertainty, while it may be somewhat miserable, there are productive ways to think about it, and it should shape the way we think about how we build models and how we confront economic policy. Thank you.
So it's time now for 5-10 minutes of questions.
Sure.
Economic theorists also draw a distinction that is somehow comparable to yours, the distinction between about the model and within the model. What the theorists distinguish basically is what they call uncertainty about the state of the world, distinguished from uncertainty about individual decisions and policy decisions that generate the possibility of multiple equilibria.
Right.
I think there is some analogy between these two ways.
Yeah.
You have any comments?
Sure. So the type of models I've shown here are ones in which there aren't multiplicities of equilibria, but there's a lot of interesting economic models that have the multiplicity, and whenever there's models that have this multiplicity of equilibria, there's an interesting question about how would the people in the economy kind of coordinate on one or the others of these equilibria. Given that there's potentially multiple equilibria out there. So what I think it would be fascinating to do, and some others have barely scratched the surface on this, is kind of think about these concerns about uncertainty as they interact with this multiplicity. And so which among a set of equilibria is the appropriate one is a potentially very interesting notion of uncertainty that's also kind of endogenous inside the model. And I think using these concerns about model misspecification and ambiguity and the interplay between that and multiplicity of equilibria is a very fascinating one. That's not something I've done in my own research, but I think going forward it's a potentially important endeavor to take place, and some other people have explored it or done some initial work in that area. But I think it's a rich set of it's a rich question to be considering in the future.
And I would like to invite you for lunch, which is going to be just over here. Thank you. Thank you for coming.